Today, we will learn about equivalent ratios. Rahul has 18 red marbles and 30 green marbles. Here, the number of green marbles is higher. Can you tell me how many times is the number of red marbles of the green marble? Think. Okay, let me tell you. Here, if we multiply the number of green marbles, that is 30, by 18 by 30, we will get the number of red marbles, that is 18. So, we can say that the number of red marbles is 18 by 30 times the number of green marbles. Or, we can say that the number of red marbles is 18 by 30 of the number of green marbles. Here, we have compared the two quantities like this. How much is one quantity of the other? Or, how many times is one quantity of the other? A comparison that tells us that one quantity is how much of the other or one quantity is how many times of the other is called a ratio. We express the ratio with a colon sign. For example, here the ratio of the number of red marbles to the number of green marbles is 18:30. This shows that the number of red marbles is 18 by 30 times of the number of green marbles. We can also express this comparison in reverse. Just like the number of green marbles is obtained by multiplying the number of red marbles by 30 by 18, we can say that the number of green marbles is 30 by 18 times the number of red marbles. That is, the ratio of the number of green marbles to the number of red marbles is 30:18. By looking at these two ratios, you must have understood by now that in a ratio, order is very important. Any ratio can be expressed in its simplest form. To do this, we first express the ratio as a fraction. For example, here we will express 18:30 as 18 by 30. Then, we will divide the numerator and denominator of the fraction with the HCF of the numerator and denominator. Here, the HCF of 18 and 30 is 6. Dividing both 18 and 30 by 6 will reduce 18 by 30 in its simplest form to 3 by 5. Then, we express it in the form of a ratio. Just like 3 by 5 can be expressed in the form of a ratio as 3:5, 3:5 is the simplest form of the ratio 18:30. Here comes another important point. Ratios 18:30 and 3:5 both have equal values and are called equivalent ratios. Okay, is there only one equivalent ratio for 18:30? Think a bit. Let me tell you. If we write 18:30 in fraction form and then divide its numerator 18 and denominator 30 by 2, then we will get the new fraction as 9 by 15, which can be written as 9:15 in ratio form. Since both the numerator and denominator are being divided by the same number, the value of 9 by 15 will be equal to 18 by 30. This means 9 by 15 is an equivalent fraction of 18 by 30. Or, in terms of ratio, we will say 9:15 is also an equivalent ratio of 18:30. Similarly, in the fraction 18 by 30, if we multiply both 18 and 30 by 2, then we get a new fraction as 36 by 60, which is 36:60. This is also an equivalent ratio of 18:30. In this way, we can now say that a ratio can have many equivalent ratios. Now imagine you're given two ratios. For example, 9:15 and 6:10. Now compare these two ratios. First express them as fractions. For example, 9:15 becomes 9 by 15 and 6:10 becomes 6 by 10. Then, convert them into fractions with the same denominators. Since the LCM of denominators of both the fractions is 30, make the denominators of both the fractions as 30 so that their numerators can be compared. To make the denominator of 9 by 15 as 30, multiply both the numerator and the denominator of the fraction by 2. This will give us the new fraction as 18 by 30. Similarly, multiplying the numerator and the denominator of the fraction 6 by 10 by 3 will give us the new fraction 18 by 30. By doing so, both the fractions become 18 by 30. When the denominators are the same and the numerators also become the same, they are called equivalent fractions. Like here, 9:15 and 6:10 are equivalent ratios. Now let's compare 1:3 and 3:4. First, express it in terms of fractions, like LCM of denominators 3 and 4 is 12. So make the denominators of both the fractions as 12. 1 by 3 into 4 by 4 is equal to 4 by 12, and 3 by 4 into 3 by 3 is equal to 9 by 12. Here, 4 by 12 is lesser than 9 by 12. Notice that both the fractions are not the same. Instead, 4 by 12 is lesser than 9 by 12. Therefore, 1:3 and 3:4 are not equivalent ratios. If two ratios are equivalent ratios, then they're in proportion. For example, since 9:15 and 6:10 are equivalent ratios, they are proportionate and are expressed as 9:15 is in proportion to 6:10 or with a double colon. In any statement of proportion, four numbers are expressed in order. These numbers are called terms. Of these, the first and the fourth terms are called extreme terms, while the second and the third term are called middle terms. You must have now understood the concept of equivalent ratios. Can you think of some examples of equivalent ratios? Try it. Today, we learned about equivalent ratios. We will look at some examples in the next video.